going to cross the x-axis. Where are my x-intercepts? And because I'm in factored form, I know exactly who they are. Okay? So let's have a quick conversation about what those x-intercepts are.
It's -2
Multiplicity?
Yeah.
Yeah, you got it. So the x-intercepts are -2, and his multiplicity, good job. Remember it. What is his multiplicity? 2. Multiplicity, think about multiplication, means something that's been repeated. Right? Repeated addition is what multiplication is, over and over again. So multiplicity means this is a repeated situation. Its multiplicity is 2 because it repeats twice. Its power is 2. Okay? The other x-intercept at play is +3, and his multiplicity is implied to be what?
1.
Well done. Didn't fool anybody. Okay. Now, how you decide to write that on a test, there will be a big piece of paper. You can write out all your details that I asked you for. So some people like to make a nice little chart for me, x-intercepts, multiplicity, whatever keeps you organized. But as long as the information is correct, I'll get you credit for it. Okay? All right, so x-intercepts are -2 and 3. Multiplicity for this one is 2. Multiplicity for this one is 1. In your previous college algebra class, hopefully they told you what that meant, right? If you had even multiplicity versus odd multiplicity, those tell you different things. If you forget which is which, because one of them is going to say, when I hit that x-intercept, I'm going to go through the x-axis. The other one says, when I hit that x-intercept, I'm going to touch it and turn around. Okay? So to remember which one is which, I personally like to remember 2 basic graphs from my library of functions, y equals x squared and y equals x cubed. If you think about y equals x squared, the vertex is at the origin, it touches that x-intercept and turns around. So x is raised to the 2nd power, which is even. It touches the x-intercept and turns around. But for x cubed, it's a snake. It touches the origin, that's its x-intercept, and it goes through. So with degree 2, it touched and turned around. With degree 3, it touched and crossed. Okay? So I like to remember those graphs, and then I don't have to memorize anything new. Okay? So when I have an even multiplicity, just like x squared, I'm simply going to touch. Some professors might have taught it as bounce. You don't actually cross. Okay, so you touch or you bounce at that x-intercept. So this is what we call, on my test and in the homework, the behavior at the x-intercept. That's what they're referring to. What's happening at the x-intercept? Are you going through, or are you just touching and turning around? On the other hand, when I have odd multiplicity, like the snake x cubed, we're going to touch it and then go through it. So we're going to cross. Some professors might have said cut through the x-axis. So currently, with that information, I know the end behavior of my graph. This was a degree 3 situation, and I know what's happening at each x-intercept. I could draw a little sketch, couldn't I? Yes, I could. I know, first thing I would do is put my x-intercepts on the graph. My x-intercepts are -2 and +3. Those. I also know the end behavior. Let's switch colors here. The end behavior is as x goes to the left forever, y goes down forever. As x goes to the right forever, y goes up forever. So as you're allowed to go to the left forever, we're going down forever. So we're going like this. And as we're allowed to go to the right forever after this x-intercept, we're going up forever, like that. So my end behavior allows me to finish what's happening at the end of the picture, on the ends, on both sides, as x goes left forever and as x goes right forever. Now I would finally, to finish him off a little bit more, I could discuss what's happening at the x-intercepts themselves. At -2, since it came from this factor up here, whose multiplicity was even, it's going to touch and turn around. So it's going to touch or bounce off. So it comes up, it touches it, but it doesn't cross the x-axis, it turns around. So this was a turn.
So it touches -2, right?
It does. It actually exists here. So we would say this is a touch, or a turn in this case. Touches and turns around. So it actually exists there. You're right. And then it turns around from there. Now I know at some point here, if I was drawing a more detailed sketch for my audience, I would know at some point it's going to have to cross this y-axis, isn't it? In fact, every polynomial, because it's continuous left to right, would have to cross the y-axis at some point. Because it's going to be going this way and then eventually turn around, we know that somewhere down here is going to get crossed. So how do I find y-intercept just for kicks and giggles? And I will ask for these. Well, you let what equal 0? Well, you let x equal 0. Good. So I go back to my original, which was y equals x plus 2 squared times x minus 3. If you let x equal 0, you can get that y-intercept, can't you? 0 here, 0 here. So y would equal 0, yeah, 0 plus 2 is 2, so 2 squared. 0 minus 3 is negative 3. Yeah, 4 times negative 3 is negative 12. So now I know exactly where I'm crossing the y-axis just by letting x be 0. So that's a skill that we don't have time to reteach, but that's definitely something we expect you to remember from previous math classes. So there's my y-intercept at negative 12. Okay, now as far as what we know in pre-calculus 1, okay? Before we get to calculus 1, all we know is a couple of things. We know because the degree was 3, we could have up to 3 x-intercepts. In this problem, we only have 2 x-intercepts because one of them is repeated. Okay? But you can think about that. We've accounted for all 3 possibilities because one was repeated. We also know that we could have up to how many turning points? 2, because the degree minus 1. Yep, the maximum number of turning points is always the degree minus 1. So with that information, I know that my degree was 3, so 3 minus 1 is 2. So I could have up to 2 turning points. I've already used 1, haven't I?
Yeah.
Here's one of my turns. So I know I can only turn 1 more time, right? So if you try to make this all squiggly and fancy, that's not true, right? You can only turn 1 more time. Okay, so at some point it's going to turn. Now, do we know it's turning here? No. Until we get to calculus, we don't know where that turn's going to be. So in Calc 1, using derivatives, we learn where these turning points are going to happen. The only ones we know in pre-calc is if we had an x-intercept and we turn around right there, right? That's the only time we'll know that, okay? Or if you have a quadratic function and you know how to find the vertex, right? Then we know what that turning point is. But beyond those 2 items, in Calc 1, that's where we're going to actually learn that. So right now, if you were drawing this sketch, you'd say, here's all I know. I know that I have to, at some point, hit this y-intercept, right? I might turn around there, or I might go a little bit lower and then turn around. That part, you don't know yet, so I'm not judging your skills there. Just make sure you show me that you do go through the y-intercept and at some point you turn around. Okay.
Can we like turn around just right at the 12?
Yeah, you could, but just make sure you're telling me I think that's what's happening, but I don't know. Like a little question mark. I don't know where it's turning.